is on the call from around the world. My name is Tim Baechle. I'm the Vice President of Idealliance, and this is the Idealliance BrandQ webinar series. This topic today is on managing optical brighteners with brand color. We're so grateful that you guys have taken time out of your busy schedules and evenings to listen to this webinar. BrandQ is a packaging supply chain certification program. It's multi-tiered. It's around the world in our 11 offices. So pleased to have Ron Ellis, the chair of the Print Properties and Colorimetric Council for Idealliance, on the call. Also President and CEO of Ron Ellis Consulting. Marc Levine, the Director of Enterprise Print Quality at Schawk. And Peter Pretzer, Development Manager at FUJIFILM, ColorPath Solutions Development Manager at FUJIFILM. So thank you all for being panelists today. And with that, I'll hand it over to Ron Ellis.
Yeah, great. Okay, thanks everyone for joining us, and we'll get going here. My name is Ron Ellis. I'm a consultant who works with printers and brands and work a lot in the Northeast and a little bit around the world. And chair of Print Properties and a G7 expert and trainer and brand trainer. This is Peter Pretzer. He was introduced by Tim just a moment ago, but this is what he looks like. He's at Fuji ColorPath Solutions Guy. But for today's topic, it's really important because over the last probably 7 years, Peter's done a lot of research on OBAs. So one of the groups that has contributed, or companies that's contributed quite a bit to our OBA research, has been Fuji. And Peter has been great at helping us and working with all that. And you're going to see some examples he's going to show of what he runs into and what they've found.
Ron, your screen's not up.
Really?
Yeah. So Peter doesn't look like a grayed out screen.
All right, hang on.
Monday morning.
He's much more handsome than that. I've seen him many times.
Let me share it a whole different way. I'm going to share it a whole different way. So, okay, if I share it this way, oops, wrong presentation. Can you see my screen now or no?
Yeah.
Yeah. Okay, so that's.
We see part of it. I see only part of the slide.
You really don't see the slide.
Now
the whole thing or nothing? Okay. So that's Peter. There's Peter Pretzer. So, and he'll be presenting in a little while. The other presenter we have is Marc Levine, who's Director of Enterprise Print Quality at Schawk, and he spends quite a bit of time on this as well, and he has a really good color management background. He worked for Monaco and for X-Rite on their profiling products, and has a pretty good knowledge of this as well. Before we start, we're going to talk about optical brighteners with brand colors, and I'm going to kind of outline the problem and show a little bit of information on the OBA issue and how we detect OBAs and know if they're there. Marc will talk a little bit about OBAs and brands. And then Peter is going to show some examples and talk a little bit about the research Fuji has done and some of the things that they've found. So pretty good information. You've got a group here that spends a lot of time fighting the OBA battle, which is pretty much what it is. Before we do that, I'll talk about BrandQ, which is sponsoring today, our presentation, and just going to go through it really quickly. BrandQ is a program that Idealliance has, and the whole idea is enabling the supply chain and the brand to communicate. We help them communicate and understand how to talk to each other. We work on education so that they understand what they're talking about, and then validation. How do we tell if color is good or not good? So that's the program. You can see in education here, this is a bunch of brands who are going through training. So these are all brand designers and marketers and owners going through training at one of our sessions. Same here, that happens to be Peter on the far right, and Marc Levine's the next with his hand on his, and I'm over to the left, but that's at one of our brand training classes. Validate, we have a whole bunch of methods and ways we teach brands as far as how to read and understand what is printed and how to correct it and make it be the right color. And before we do that, I'll show one last thing related to that, and then we'll flip right into it. So this is from our last brand training class that we had in Korea a few weeks ago. Just to give you an idea, this shows some of the students here learning how to measure. You can see them working. This is our Idealliance India guy, Selvin. And then we've got different brand and expert people from, this happens to be in the Korea region. Yeah, so you can see they're learning how to measure, learning how to see how color is, learning about some of the issues and how to talk about it and communicate it. So I'm going to flip out of there and I'll go back to our presentation. And what I'm going to do is talk a little bit about why OBAs matter and why OBAs are important. So the reason that OBAs matter is they're probably one of the biggest issues with color matching. And the big issue with OBAs is that we can get really good numbers that say that our color is what it should be and that it's correct, but our visual will not match. So a typical thing, I ran into this with a brand this week where they were trying to match a proof that was being produced by Schawk in China, and basically their proofing paper was adhesive with high OBAs. And what you see on the screen here is similar to what would happen. So the bottom two papers on the right are proofing papers. The three papers above it are press sheets. And you can see that in the viewing booth, the ones with the OBAs look quite different. And just that color difference there is usually enough to make a proof and press match really difficult. So OBAs are really a big deal because if you're trying to get a good color match, having OBAs complicates it and makes it much more difficult. If you think about it, one of the complaints that people have is that, hey, I've hit this to the numbers, I've got the ink the right color, I've got my G7 the right color, my spot color is the right color, how come it doesn't match the proof? And if we have this OBA difference that you see here, it's pretty much almost impossible to get a match. One of the other issues about OBAs is they fade over time. So if you leave something with OBAs out in the light, that substrate will fade and change and become yellower. And for something that gets thrown away like direct mail, it may not matter, but for a product that sits on a shelf or something that's more permanent, OBAs can be a big challenge because the color will change just by being exposed to light over time. So OBAs make calibration and color matching much more difficult. This picture that you see right here is the picture on the right is my customer with the adhesive, and you can see, you know, what that looks like. And then on the left is the proof from overseas, which is on a regular standard proofing paper. And you can see that difference there. So both of those are calibrated to the numbers. They're both correct. So if you look at the paper tin over on the right, you know, over there, and if you look at the paper on the left, those are supposed to be the same, and numerically they're the same, but visually they're different. So that's a little bit of what you see with the OBA issue. But it makes this color match really, really difficult to do. And we'll talk about it in just a minute, what we do about it. OBAs are used in lots of different substrates. Look at the stack on the end of this press here, and you can see that I got a paper on top that has a lot of OBAs, a paper in the middle that has a little bit of OBAs, and then I've got a paper on the bottom that's pretty neutral. So these OBAs, you're going to find them all over in printing plants, especially with the inexpensive stocks. That's where they're going to have them, using them to make the substrate look a lot brighter. And then you should also be aware that some of the coatings out there, like UV coatings and such, also may have OBAs, and that will actually cause a color matching issue as well. So OBAs are pretty much everywhere, especially in the paper supply chain, because it's a way for them to make the paper brighter that doesn't cost too much money. Take a look here. You can see top one with some OBAs in the bottom. So these are two different versions of Grackle. So on top we have you know, the newer, bluer version. Below that we have the older version. Top version has a little bit of OBAs in it, and you can see that visual mismatch. So calibrated both to G7, but you know, the grays and everything are affected by this. So the big question is, how much OBA is too much OBA? Because the first question is, do the stocks that you print on have any OBA in them? If you're packaging and you're doing boards, then there's a good chance there won't be any. But if you're printing on the commercial side or on something that's a brighter packaging board or substrate, then you may have OBAs. Usually a little teeny bit of OBA isn't a problem, but if we have a lot of OBA, then it makes calibration and measurement really problematic. So when I say a little bit, we tend to, one way to assess OBAs is by the B value of LAB. And if we looked at a little bit, it might be like Grackle 2013 or ISO 12647-2 2013, and that has a B value of -4. So a little bit of OBA, but not too much. But if I looked at another extreme, which would be a very premium coated sheet that people use out there, that has a -10. And that amount of OBA becomes really problematic for proof to press matching. So it's a really bright sheet, but getting proofing paper like that and being able to match it becomes really, really difficult. You can see right here, here's a whole spread of a whole bunch of sheets that a printer's spread out for me. And you can look at the range here of super, super bright OBAs on the right. And in the middle, we've got some stuff with OBAs, and then we've got some more neutral stocks there. So they pulled all those from pallets off their floor, lined them up for me, took that picture, and gives you a pretty good range that there's a lot of OBA out there. And if you look at the difference between the substrate colors in these sheets, just the color itself would shift quite a bit based on this range of OBAs there. We can measure OBAs and we can quantify it, and that's one of the first things when I go into a printing plant or begin working with a brand is I say, show me your substrates, and begin to measure it to determine if there is a high level of OBAs in there. If there is, then I immediately say, okay, well, we've got a challenge here. If there isn't, then I just go about my business and don't have to worry too much about it. But if there is, then I know that I've got my work cut out for me, and it's okay. That's how I make a living, but it definitely makes things harder for both the printer and the brand. One of the ways that we can check the level of OBAs is by using this OBA index. And it's a measurement where we take M1 and basically, take the difference between M1 and M2, and then we go on a scale. The screen that you see here is from a TeshCon SpectroDens. It happens to have an OBA check function. And so you can see on this one, I clicked on a paper. It did the math to do the difference between M1 and M2. And from that, it gave me this number 8.9, which on that scale tells me that I have high OBAs. That's one easy way to tell if something has OBAs is to do that little equation, and you can figure out what is the level of OBAs and where does it fall on the OBA index. If you look at that scale, it's right here. So you can see, from 0 to 1 is none. That would be like a Grackle 2006 or older ISO paper. Then as you move up, we have low, which would be Grackle 2013 in the middle, and then up into the higher OBAs. So that's the official way that we measure OBAs and tell how much OBA is in the paper. Another way, if you don't have that piece of equipment or a spreadsheet or easy way to do it, is you could just basically take and look at the B value, the -B value. And what I do, if I quickly read a piece of paper with LAB with M1 measurement turned on, if that paper is higher than a -6B, then I pretty much assume that I have a high level of OBAs there. So you can do it that way as well. That's kind of a quickie, cheapo way to check the OBAs. And then on the screen right there, you can see if you happen to have a viewing booth that has UV energy in it, you can flip that on. You can actually visually see the OBAs here. So the blue papers are high OBA stocks. You can see they're picking up that OBA. And then on the right, we have normal proofing stock. And you can see that has no OBAs. It doesn't ignite. It doesn't glow. It doesn't do anything. So that OBA is our brighteners that are put in the paper. And when the UV energy from the viewing booth hits it, it basically lights those up. So some of the things that make this complicated for us, the first thing is viewing and measurement conditions changed. So in 2009, we got new ISO standards, and these standards included UV energy. They didn't used to actually have UV energy in it before 2009. So everything before then never really illuminated and lit up, and daylight maybe wasn't quite as bright in the viewing booth as real daylight. So that was all changed and adjusted, and both viewing and measurement conditions were given a defined amount of UV energy to put into it. The next point there, that number 2 bullet point, is my opinion. And my opinion is the updated lighting has way too much UV energy in it. It tends to light things up more than daylight would. But that's what causes part of our viewing issue. When you walk into a booth, you know, if I looked at this outside of the booth, it wouldn't look like this. They'd look similar. When I walk into the booth, it lights up. The updated measurement condition is called M1. So when you're measuring something that has a lot of, excuse me, a lot of OBAs in it, you're using something called M1 measurement mode. And that's basically pushing that UV energy down and then measuring it back out. The other complicating factor is the lighting. The viewing condition that we have is not the same in our viewing and our measurement. So there is Don Hudson had done some calculations, and he had basically come up with about a 3 delta U difference between the light source in our instruments and the light source in our viewing. So that's another complication. Even though they both have UV energy, they're not exactly the same, so that causes a little bit of an issue as well. So that same thing for us begins to give us an issue. So one thing to remember about that is the white point. And the white point is really important. So what we're talking about when we're detecting the OBAs is looking at the white point. And one of the big ideas here is if that white point is too different between your reference print condition and the paper you're on, or your proofing paper and the paper you're printing on, then you're really not printing to the same print condition. So, you know, that's the kind of the big thing we have to watch for. And so if you go back to this slide here, you know, that's it. If that white point, no matter what we do when we print on this, they're not going to look the same. They're too different. Two different print conditions at that point. Grackle on this is not really grackle. Grackle on this would be grackle. So that's important. The next part is how do we minimize it? How do we stop these OBA issues or minimize what happens? Obviously, the first one is don't use OBAs. If you can knock OBAs out of your workflow, then it's color management like it always used to be. Works well, very easy, very simple. And in the packaging world, if I'm on an SBS or something with no OBAs, then I know it's pretty simple work to do. But that's not always possible, so very often we may have OBAs in our papers. So in that case, we're going to use our M1 measurement mode. So we're using M1 in our device. Second thing is we're going to make sure that we have new bulbs that have the UV energy in them that is somewhat close to our measurement device. And then we try to correlate the amount of OBAs in the proof and the press sheet. Now what that means when I say correlate is I'm trying to make sure that I have the same amount of OBAs between the press sheet and the proof. It's not a perfect way to solve it, but if the OBA level is similar, then I have a much better chance of getting a good color match. So I'm going to try to make sure I correlate the level of OBAs, meaning if I'm proofing, if I'm printing on a surface that has OBAs in it, I'm going to try to make sure my proofing has similar OBAs so that I get a similar look. Then also keep in mind now that there are new proofing stocks that have OBAs, and there tend to be 3 different levels of them. So there is no OBA, which would be the old proofing paper we're all used to. Second one is a minimal OBA that has a -4B, and that's usually a stock that's called proofing OBA or something like that. And the final one, there's some stocks out there that actually have -10 or -9 OBAs for super bright. So if you talk to whoever you buy proofing paper from, they can kind of point you in that direction and give you some info. Don't forget to check coatings. So coatings are important because very often they have OBAs in them. And usually if I can correlate my proofing paper and my press sheet or multiple papers to have the same level of OBAs, I get a much better color match. But sometimes it still doesn't work. So just be aware in the world of OBAs, that's where we end up having issues. So that's kind of my quickie, and we'll have questions at the end, and you can ask more questions about that. So I think now let's flip it over to Peter. And Peter, you can show us some pictures and talk a little bit about your experiences.
All right, Peter, I just sent you control. Just go under the top file, edit share, and choose share my screen.
Just doing that, and
perfect.
That's not it.
Oh.
Let me.
While Peter's doing that, just to remind everybody, you can ask a question by typing it into the chat box on the right side of your screen. You can ask that any time, and as Ron mentioned, we'll take the questions right at the end.
Okay, are you guys seeing a screen now?
Yes.
Yep, Salesforce.com.
Ah, so I did have the right screen up. All right, here we go. So what we've done here is we've measured a whole bunch of different papers from different suppliers, and we kind of keep a database of what the LAB values of those papers are. And you can see here, I've just sorted these by the L, A, and B values by brightness. So you can see the range here kind of goes from we're going all the way from those low ones with almost a 0 A and B star to up to a -14 B star and an A star of 4. So you can see things go from pretty red and blue down to fairly neutral. So the half the battle, or I should say all of the battle, if you're trying to proof to these, is to find a paper that matches what you're printing on press. And what you can do these days is there are tools out there. Idealliance has got a spreadsheet published where you can actually start with a reference data set, such as Grackles 2013, and if you know what the LAB value of your paper is, you can plug in a new value, recalculate the data set, build a profile of that new recalculated data set, and then proof to that on a paper that corresponds to that white point. And as Ron said, we see papers that run from we see about 3 or 4 out there that have various levels of brightener and for proofing, going from about a -10.5 B star. There's another at -6, there's another at -4, and another down at around 0. So what can happen there is, if we look at what's going on with that brightener and we measure it, you can see here a neutral paper is a delta E of 8 from the highest level of OBA that we might see on a decent commercial stock. When we start to get up into that -14 range, we don't see that very often, but -10.5, -11 B star with about a 3 or a 4 A star value, those are pretty common, and those are premium sheets and they look great. But if I proof on a neutral stock and then I print on a high OBA stock, those are going to look completely different under different viewing conditions. They might look fine with a UV cut. They might look completely different with a certain amount of UV energy. And if we look at different levels of UV energy, here's an example of, these are 2 offices. If I go in and measure these with a spectro, if I measure the cabinets or the carpeting or the paint, they're going to be exactly the same, but 2 different levels of lighting, and they look completely different. If we look at this, here's one. I've got a neutral image. Probably you've seen something like this quite often in your mail, but if I've got a different paper colored stock, whether that's yellower or bluer, the OBA is going to affect that brightener. How does the white? White becomes the 5th color of that paper. So we really have to be careful with what we're doing here. And if I look at a typical viewing booth, here we've got an example of, on the left-hand side, you can see under normal viewing conditions, everything looks quite similar, but if I start to increase the UV amount, you can start to see where things fluoresce. And those papers are going to be quite a bit different looking under those viewing conditions. So that's really what you're seeing on a less exaggerated scale.
Can you make it bigger, Peter?
Yeah.
That's the window? That's actually quite interesting.
So there we go right there. Left-hand side, we've got on the top probably about a -10 B star, and those on the bottom are the proofs with about a -2 B star. And there are viewing booths you can buy today that allow you to set up different lighting conditions. A lot of today's newer booths have LEDs in them with various arrays of LEDs that allow you to adjust those either with UV energy or without, or for D50, which is the graphic arts viewing condition, or D65, which is what manufacturing, the ISO standard for manufacturing views under. So there's a lot of flexibility today compared to what there used to be. The other thing that we have to take into account is how are retailers displaying their products? And they're typically not displaying them under perfect D50 lighting conditions, which is how we evaluate printed samples, but they might also be a much yellower or a much bluer condition. So if you need to match what your print buyer is expecting you to do, you might want to coordinate where the end product is going to be viewed, under what conditions, get a measurement of that, and try to reproduce that at your shop.
That's a pretty interesting picture.
Here's another example. Same thing. We've got papers on top that all look similar under a fairly neutral environment. This is the old ISO 3664 standard. The middle sheet shows those same papers under the newer with increased amounts of UV energy. And Ron had said earlier that he's against his opinion is there's too much UV energy. What we also need to take into account is that the UV energy is going to show off the differences that you might not see otherwise. So fewer surprises down the line that if you print on a paper that on the top looks perfect, you get it into another viewing condition, you're starting to see some differences, and then the extreme is on the bottom where we've added even more UV energy and you can start to see these things really fluoresce. So it's a two-edged sword. Some things that used to be hidden are now exposed, and some of the things that maybe we don't want exposed are heightened even more. Ron had talked about, this is another interesting one, when we first started doing research into proofing papers that had higher amounts of OBA so we could match what we're printing on, we were running these prints, and then a couple of days later they were looking different. So when Ron said light and oxygen and things like that will affect the optical brightening agents, here's an example of that. We took the CD case and just set it on top of a couple of sheets of high OBA paper, and you can see in just 24 hours they look different. Now this is heightened by high UV exposure here to show this off, but you can imagine what might happen over a month's time. So papers that might have started out with a -10 B star end up at a -4 30 days later. So when you're proofing, make sure you get a paper that is going to retain its B star level at that same level. And there are those out there. Most of the major paper suppliers today will provide those that don't fade. Excuse me, take also into account though that some of the press stocks will. So if you want a proof that's going to last a month, you've got that, but press sheets may differ depending on how they're stored or if they're exposed to light or oxygen. Okay, Ron, that's what I've got.
Yeah, no, those are really interesting pictures. And then what was if you had to sum it up in 2 sentences, your conclusion, because at the beginning of the OBA battle, we all were scratching our heads trying to figure out what the best practice is. What do you guys do when you're trying to make an OBA match, an OBA stock match a proof?
We've got probably our most advanced customers they've settled on maybe 3 levels of OBA that they're running through their Epsons. Maybe a sheet that conforms to Grackle 2013. They might have one, and that's about a -4 B star. They might have one that goes up to a -6, and that conforms to ISO and Phograph 51. And then they might have another high OBA that's maybe a -10.5. And those conform with fairly well with 3 levels. Some other folks are running only the high OBA proofing stock, and then they're putting a scum dot, they're simulating the paper cast. I can always start with a brightened paper and bring it down to a neutral by adding ink to it, but I can't start with a yellow sheet and try to make it brighter by adding blue to it. So start with a brightened sheet and go down, or have different sheets.
Yeah, good. No, that's great. Good. Well, thanks, Peter, and we'll have questions in just a few minutes. Those pictures are awesome. Marc, are you ready?
Yeah, you know, Ron, I don't have a slide presentation prepared for you today, and honestly, the discussion as it relates to brands and packaging could be a very short one, right? Because for the reasons you mentioned, brands haven't really invested in materials that will discolor on shelves. Obviously, one of the most important things to a brand is its image on shelf. It needs to be consistent, it needs to be reproducible, and it needs to persist over time. So sometimes those products are sitting on the shelf and they don't want them discolored, you know, by the UV or the store lighting. So for that reason, we're not seeing a lot of UV, or OBAs rather, in the materials that are used to produce packaging. So that's, you know, that's sort of good news for the packaging vertical. But there are some considerations that OBAs sort of impact. One thing to really understand is that, you know, when we talk about OBAs, the biggest area of influence is on the substrate, and moving to like digital processes that have, you know, different substrates than you're used to working with historically, there may be OBA issues that you want to sort of tackle head on, because it's critical for a brand when they're running a hybrid package where sometimes they run a smaller lot digitally and use conventional process for larger lots. You want those two to match. Other questions we get from brands are, is this impact, oh, go ahead. Is there a question? Sorry, I heard a question.
Keep going, we'll have questions at the end here once you're done.
Sure, sure. So the other thing that we get questions about are use of M1 with color standards, right? One of the things that brands use as a standard convention to deploy their brand across their supply chains are color standards. This is, you know, what should the color be? It's Gap blue, it's M&M yellow, it's Coca-Cola red. So brands use color standards to guide the industry so that color is reproduced consistently from substrate to substrate and printer to printer. So one of the benefits you get in that scenario of sort of suppressing the whole OBA phenomenon is that ink itself filters out UV. You know, generally materials that transmit light will filter out UV. This is why you don't get a sunburn when you're sitting in your car and the windows are closed, right? Because generally light glass filters out a lot of UV. Ink works the same way, and especially in yellow and black inks. So even though you may be printing on materials that use OBAs, still if the brand's worried about the color, OBA isn't such a big issue, because you can expect that the effect of the OBA will be effectively eliminated by a lot of colors, a lot of brand colors, just by the nature of having a layer of ink on top of it. So that's a question that we take from time to time, and you know, M1 is the latest type of measurement, so brands are interested in deploying the latest technology for their supply chains. And so these questions will come up, and it's really important to understand these to help navigate, you know, your supply chain and make good decisions about technology. The other thing that comes up once in a while is printing the standards, right? Brands are very interested in using standards to streamline their supply chains. Brands are very sensitive to cost and time to market, and they try to stay away from proprietary workflows that sort of put additional load on their supply chains. If printers have to work a different way than they're used to working for another brand, that's a bad thing. It's better if everyone's working in a standardized way. They can get the maximum throughput and kind of be doing the same process all the time. So to that extent, brands look to standards like the new CRPC datasets, which are largely based on OBA-type papers. The expectation in these new datasets is that, you know, the papers that are the foundation of these datasets have brighteners, and the numbers are built around that. So in the packaging world, when your materials don't have brighteners, which, as we said, that's the case a lot, you need to understand, well, which standard should I target? You know, if just because it's a newer one, Grackle 2013 versus Grackle 2006, it doesn't mean it's a better one, right? Because Grackle 2013 has optical brighteners built into it. And there's procedures that you can use, as you know, to take those characterization data sets and optimize them so that they better fit your application. But it really requires, you know, sort of digging a layer deeper and understanding, you know, what's my printing condition? Do I have optical brighteners? Do the target data sets I'm using have optical brighteners? And how do I work best with both? And generally speaking, I don't recommend to brands using a target characterization data set that's got brightener built in unless, one, they've either modified the data set using standardized practice to make it fit their workflow, or two, they're actually using both optically brightened media and M1 measurement. Because if you're not working with an optically brightened substrate and you're not using M1 measurement, it's very difficult to line up the measurements from your process against a standard that has been built with both of those things. So for me, it's just, you know, when advanced technical issues like optical brighteners come up for brands, my strong recommendation is to align yourself with partners who can help you navigate some of the technical choices you're making, and that's going to help your supply chain process operate much more smoothly, give you more consistent results.
Yeah. A couple of quick questions for you, Marc. The number one, what about coatings, OBA, you know, UV coatings that you figure out have a lot of OBAs in them? How do you deal with that with a brand?
Yeah, we definitely have one brand who's raised that as an issue, and you know, I think that brand had an interest in taking all of their legacy data and moving from M0, which is what all the legacy measurements are taken with, into M1. And for any brand interested in doing that, I would say generally, you know, if you're not optically brightened, then it's probably reasonable to do that. There is no consistent relationship between M0 and M1. There's no math that you can run measurements through to convert them because you're characterizing the color with a different light source. And if you didn't have that light source in the beginning, you just can't forecast what you would have gotten, right? So when you don't have a lot of OBAs, then it's somewhat permissible. It's still sketchy, honestly. But if you have...
Keep going, sorry. No. Keep going.
Yeah, so on the varnish thing, the right way to do it would be to really characterize the varnish with M1 so that you're sort of incorporating the influence of that OBA into the standard that you're creating, right? And again, the question is, what are you measuring at the time when you make that standard? Is it a varnish over a color? Is it a varnish over a substrate? So typically, right, you're going to have a color standard for either a color or your substrate. So just if it's the intent that you're going to have this varnish over your substrate, you would sort of define your substrate with M1 because effectively you just put optical brighteners in your substrate. If you're defining it, you know, from a color perspective, then yes, it would be permissible to measure that color with the varnish over it to incorporate the effect of that OBA to make it align, to make the numbers align with what you see more visually. But again, that's a pretty specialized area of packaging, and it does bring a whole lot of complexity because while you're managing that, you're also managing the other stuff that may not have varnish over it, and you have to do that all at the same time.
Now, what about when you, if your supply chain extends into a region that's not the U.S., like India or Pakistan or, you know, China or somewhere, what's the likelihood that they're going to have M1 capability?
Well, M1 capability is improving quite a bit. I mean, you see X-Rite and Teshcon probably between those two companies, the lion's share technology provider for the packaging market, and they've done a great job at selling, quite frankly. It's new, and you just need new instrumentation to have M1 capability. So I would say that from a pure capability perspective, we're seeing worldwide, India, China, that the print suppliers are buying new instrumentation, and they are becoming, you know, M1 capable. I would say that the majority of the supply chain right now, from an instrumentation perspective, is likely M1 capable. The bigger challenge is just kind of keeping the workflow straight, right? Because just because you have an M1 instrument, you know, what standard am I targeting when I set up my press? You know, how are my colors characterized? How's my whole process characterized? Am I running varnish versus unvarnished? And now I've got M1 and M0, and you know, it's really the complexity of the workflow that you have to sit down with a qualified partner and make good choices based on the latest available technology.
Yeah. What about what do you see for OBAs and flexible packaging? Is that an issue or not as much of an issue? Or
I haven't really run into it. I mean, flexible packaging, again, a lot of it is back printed, so you're going through the material just like sitting in your car, so that screens out a lot of the UV that would be hitting the surface, you know, the white ink. And again, there is white ink in lieu of, you know, hard substrate. Ink itself is a kind of substrate. And we don't see, I haven't observed a lot of optical brighteners in white inks. And just generally speaking for packaging, whether it's a carton board or whether it's a flexible pack, it's kind of the same issue for brands. They want to see that pack be shelf stable as much as possible, and they're hesitant to employ materials that will shift while they're on shelf.
Yep, makes sense. Yeah. So I think, do you have more, or should we open for questions?
I mean, those are the big ones, right? Just make sure you're choosing the right characterization data set. Understand if there's OBAs in your characterization data set that you're targeting and in your process, and try to make a good match between the two. That's just gonna, if you get those two lined up, you're on a path to success. If you're out of alignment, I think it creates challenges that you'll fight, and it'll slow your process down. It'll be difficult to deliver on time with the consistency you want.
Yeah, great. Thanks, Mark. I think we can open up for questions now.
Yeah, we have a number of questions. I just have to say, Marc Levine, amazing information, especially since the real Marc Levine couldn't make it, so we had to fill in Marc Levine, and he was quite knowledgeable. The fake Marc Levine was extremely knowledgeable and pulled that off. So amazing. So
yeah, hey, Tim, there's actually 7 of us.
That's incredible.
You just don't know what
you
don't know which one you're going to get.
Well, I need that list in case the other ones are not available at other times as well. So there's quite a bit of questions, so we'll get to them. The first question was, we talked about it, I have to translate some of the back-end stuff, is how many OBAs mean too much? And I think, Ron, you get to -6 B star, and you have quite a bit of B.
That's my approach, but it really depends on, for me, and just the practical sense of the word, it would be -6 would be about where things get a little more difficult. But it all depends on your proofing substrate and what type of match you're trying to do. Peter, you probably have an opinion on that too, I would think. How much is too much?
He might be on mute.
Peter, are you still there?
I'm here. I'm here. What was that, Ron?
How much is too much? How much is too much? Like, where do you start thinking, oh boy, this is going to be a challenge?
Well, the rule of thumb is that we see for international specs is between 2 and 5 delta E, and I find that starts to be a challenge. So the difference between the 2 substrates, anything above 5 is definitely a challenge. I just want to piggyback onto something Marc Levine said earlier about instrumentation, and it's starting to get to the point where any devices that are not M1 are pretty old, and they're probably about 5 or 6 years old, so they're beyond their point of factory calibration anyway. So it's probably a good practice to, if you've got some of those devices, like say an I1, invest a little bit and get a new M1 capable device, and you're going to solve a lot of problems.
Yep.
Great, nice.
Great.
Next, another question was, is it put in a light booth? So is the substrate put in a light booth with UV light? And the answer is there's all kinds of light, different light booths with different types of lighting. And Peter, why don't you answer that? Because you actually talked about the different light booths, the different types of lights, and different types of lights you use in your facilities.
Yeah, so standard fluorescent lamps have been out there for years, and they have a certain amount of what we call spectral power distribution in at a certain area of the spectral curve. LEDs will put out different spectral power in different parts of the visible spectrum. So some of the manufacturers they've built arrays using different colored LEDs to get a nice even simulation of what we call D50, or the spectral power distribution that we've agreed to use for evaluating prints. So we found that we can both save energy and replace lamps less often if we switch to these LED-based fixtures. The LED-based fixtures also allow us to apply different amounts of UV. So as I mentioned earlier, we can view under D50 conditions, which are the print evaluation conditions. We can evaluate under D65, which are conditions that are standardized for manufacturing, general manufacturing. We can also view with increased amounts of UV turned on or off. So the LEDs give us a little bit, quite a bit more flexibility. They tend to use less energy than lamps do. And the other thing is as soon as we turn them on, they're instantly accurate, where lamps take about an hour to warm up. The other thing is we can very easily calibrate the LEDs so that they are almost exactly the same from location to location, from light booth to light booth, and so you can standardize on an LED-based system, use it with confidence across the world, whereas with lamps you'd be varying quite a bit, also based on when those were turned on or off. Great.
There was a question from a print manufacturer saying his current paper CIE lab values are 91.30 and negative 0.3, and when they tried other paper and went to 90.3, 0.7, and negative 1.5, the gloss value increased by 8 units from 84 to 92. So was the difference due to the OBA amount?
A minus 1.5 has almost no OBA, so that would be a difference in gloss and not white point.
Right, that's surface. Yeah.
Yeah. Yeah, usually when you see a difference in gloss is a measure of basically how the substrate scatters the light, right? So chances are if you've got two different materials that were manufactured at two different times and likely with two slightly different processes, that's really the reason for the difference in the gloss. So you just happen to be seeing both the difference in the gloss and the difference in the B star.
Great. Another question was, how would I know that OBAs have been included in CRPC datasets?
That's a very good question. That's one where the print buyer and the print provider are going to have to get together and decide how they want to communicate that. So the print provider should be adhering to a request from the print buyer that they have the same LAB values for those paper types. And then you're going to have to say that, hey, this is, so what we would do tend to do at FUJIFILM or recommend here is that somebody name their profile with the CRPC it's based on, and then they also supply the LAB values for the paper white point. So, for example, if I've got a profile based on a brighter stock, I'm going to say CRPC 6, meaning it's based on the Grackle 2013 color space, and then afterwards we indicate the LAB values, typically in integers. If it needs to be tighter than that, in tenths of integers, tenths of a percent or hundredths, name it that way. But Make sure that everybody's on the same page as far as how those things are named and what the expectations are.
And the existing CRPCs are all measured with M1, or all specced with M1, but you can look at the B value to figure out which ones would have OBAs or not. So if you looked at 5, you know, that's pretty neutral, doesn't have OBAs. But if you looked at 6, that's the -4. If you looked at 3, that's a little bit brighter. Those have a little bit of OBAs. But pretty much looking at the B values of the existing CRPCs gives you an indication of the, you know, that base CRPC and whether that has any OBAs in it.
And a quick way to check, the ICC, so color.org, which is the ICC website, maintains a list of all the CRPCs and published profiles. You can go click on the data set. It opens right up into a text file, and you can, typically the first patch is the paper white point.
Yep, and also graphel.org, you can download the print standards book, which has a chart that shows all the white points as well.
Hey, yeah, this is Marc. Just one more footnote, and it's really for you, Tim. I think this is a great conversation, and these kind of questions are what makes meetings like this great. I think that's a recommendation that Idealliance should take back to their ISO teams. And with the publishing of these characterization data sets, we should indicate which ones have what level of optical brightener in them. I think that'd be, if it's not being done already, which it might be, I think that'd be a great add.
Yeah, no, it's not, so that would be a good one.
That's a great point, Marc. You're full of great things today.
I'm full of something.
No, that's a good one, and we are working on 12647-2, revision. So that's actually a good point.
That is an excellent point. Well noted. We have a lot of questions to get through. So, is there an OBA index feature in the exact advanced?
I do not believe there is, but I could be wrong. But in the one I have, I haven't seen it.
I don't.
Peter, do you know of one?
I don't.
Yeah.
Okay, I'm going to read this one straight through. I'm obviously reading these first times as I just scroll down. What is the effect of OBA amount variation with incoming material? Do we see color issues, color inconsistency? So I'm interpreting that as incoming material, meaning that variation of substrates that they're purchasing or material that may be finished or going on shelf. It could be interpreted multiple ways.
I don't know if it's any worse than any other paper coming in, but obviously it has that fade issue if it's sitting somewhere over time.
Actually, that leads into another question here about in your experience about the fading process. Does most of the fading happen in the first few hours, days, or does it take weeks and months to fade? This is actually a great question because, Peter, we talked, you did this study, we talked about this in detail, I think at a PPC meeting, because you had this running study on fade, right?
Yeah, it depends. It depends on the paper, and we found noticeable results in 24 hours, but most of them took about 30 days to be visible. So you could measure it within a few hours, but visible results in about 30 days.
Okay, great. And then, oh, they're popping up. Sorry, I had another question here. Is it value-added measure to measure the CIE lab of incoming material on a regular basis? And yes, so.
Yeah, it's great. Good thing
yep.
to do. And if you have any automated measuring at all, you'll see it on your press sheets as you're printing as well.
Yeah.
And we see this in different parts of the world in regards to people that measure substrates routinely and others that don't measure substrates routinely. As we process millions of measurements per year, so it's interesting statistically. So another question was, what was the name of the tool you mentioned earlier that can help to calculate the data set of putting in the LAB values of the substrate? And that was the reference data set calculator.
Oh, that's the substrate relative calculator, which you can get at the Grackle website. So grackle.org. You should be able to download it there. And
yeah, the substrate relativity calculator.
And lots of software does it too. So there's actually, you know, lots of little cool programs that do it as well. But you can grab that spreadsheet and then you do that calculation and you can load that into your RIPs and make profiles and stuff like that.
And I can vouch for lots of little cool tools that do that. You can talk to some of your suppliers and find out about those.
Yep.
And that was the end of the question. A quick note that just quick typo. The next training, the next BrandQ live training is being hosted by Microsoft, their world headquarters in Redmond. It's actually the 18th to the 19th of September.
Okay. Well, that's good. I need to know that.
Yes. As the lead trainer and person doing the class, no, I'm glad. So it's at Microsoft. Thank you. If Microsoft, I believe Microsoft is on this webinar. Thank you so much for hosting that training. We're so grateful to work with you, and thank you for hosting. And thank you to our panelists today. It's always amazing to have your knowledge on these calls and for everyone that attends as well.
It's our pleasure, Tim, and thanks for having us.
Yeah. Good. Great. Well, have a good weekend, everybody. Have a good 4th of July if you're in North America and or in America. If not, enjoy the weekend and have a great week. And we'll have another topic coming up for July, and look forward to seeing you guys then. Take care.
Thank you. Thanks, Ron. Thanks, Tim. Thanks, everyone.
Thank you, everybody.